Welcome to conditional probability using the formula. In the last video, we did conditional probability using a two-way table. So take a minute through the do now because we're going to refer back to it after this. So for the first one, we have what is the probability that a randomly selected student would choose London? Now this is basic probability. There are no conditions or any funny stuff going on. So the number of people who chose London was 170 out of the 510 total, right? For part B, what is the probability that a randomly selected student was a senior and would choose London? So because we're talking about and probability, that means we need the intersection of senior and London. So senior and London intersects at 80. So we have 80 over the total amount of students of 510. Now, notice in the last one, we have what is the probability that a randomly selected student was a senior, given that's your keyword, that they would choose to go to London. So what comes after your keyword is the denominator. And that's the column or row that we're going to be looking at. In this case, London is our column going downwards. So that means London is going to become our new denominator. That's why we have a denominator of 170 people who chose to go to London. Of those 170 people, 80 of them were seniors. Again, if you need more help with Part C, refer back to the last video on conditional probability using the two-way table. Now, we're going to go back to the do now with our answers. And for the do now, we got 170 over 510, 80 over 510, and we got 80 over 170. Now, in this video, we said we were going to talk about the conditional probability formula because you do not need to use a table in order to get it. So, recap of the notation for conditional probability. A line B means A given B, right? So that's what this one means. And this is your intersection, right? That is your and probability. So the formula goes that the probability of A given B is the probability of A and B over the probability of just B. And notice how what comes last after the slash has to go in the denominator as well. So this still applies. For example, the last one, given that they would choose to go to London, that came after the keyword given, so that should go in the denominator here. Now, we're going to use the do now and verify that the formula actually works. So we have the probability of senior given that they go to London. That means that the conditional probability should be the probability of senior and London over the probability of just what's in the what comes afterwards should go in the denominator. So over the probability of just London. Now the probability of senior and London was 80 over 510. The probability of just London was 170 over 5/10. So the nice thing about the formula is that the denominators cancel out because the two overall totals are the same, and you're left with just 80 over 170. If you didn't know that the denominators didn't cancel out, just use alpha y equals on your calculator and it'll simplify the complex fraction for you. Let's try another example actually using the formula. So in a school of 1,200 students, we have 250 are seniors, 150 students take math, and 40 students are seniors and are also taking math. They want to know what is the probability that a randomly chosen student who is a senior is taking math. So there's not necessarily a standout key term here, but they are saying a randomly chosen student, and they're saying that that student has to be a senior. So this is going to be your condition, in other words, your denominator. Usually if there is a comma in the question for probability, it's usually going to be a conditional probability type thing going on because the comma is where the condition is being explained. So in order to do this, let's look at what we actually have. The probability of being a senior, because that's our condition, so we need that in the denominator, is 250 of them are seniors out of the 1,200 students total. We also need and probability. So the probability of senior and math the problem says there are 40 students who are seniors and take math out of the 1,200. Now, with that information, we could come up with the formula, which is the probability of A given B is the probability of them both over the probability of just B. Again, what comes after the slash goes in the denominator. So we have the probability in this case of math given seniors, the condition, is the probability of math and senior, or senior and math, whichever one you want to put first, doesn't make a difference, over the probability of just senior. And be careful, please don't use the probability of just math. Your condition always goes in the denominator. So the probability of math and senior was 40 over 1,200. The probability of just being a senior is 250 out of 1,200. The common denominators are going to cancel out, and you're going to be left with 40 out of 250 as your conditional probability. So keep in mind, if you notice that a condition is being given, but there's no two-way table, you have to use this formula. So in this example, we have historically a given day at the beginning of March in upstate New York, that should say upstate New York, has a 18% chance of snow and a 12% chance of rain. If there's a 4% chance it will rain and snow on a day, then that should say calculate each of the following. So our two probabilities we're trying to find is the probability it will rain given that it is snowing. So in this case, we have a given, and what comes after it, snowing, is your condition. So snowing should be in your denominator. For the second one, we have the probability that it will snow given that it is raining. So in this case, raining is going to be in your denominator. So in order to do the conditional probabilities, let's just write it as the notation first. That way we understand it. This is probability of rain given snow. This one is the probability of snow given rain. Now, when you're doing both of them, you do need to know the and probability, right? So the first one, we're going to have the probability of rain and snow. Remember that upside down U represents and. Over, in this case, snow was our condition, so the probability of snow should go in the bottom. That means when we input the numbers, there was a 0.04% chance of it both happening at the same time and a 18% chance, so I'm going to put 0.18% chance of it just snowing. Please make sure you convert your percentages into a decimal. Anyway, if you put that in alpha y equals in your calculator and convert it to a fraction, you're going to get 2 nines. Yes, you can leave this as a decimal. You can write it as a percentage. However, typically we go with fractions. Anyway, for the next one, we have the probability of rain and snow. And here, your condition was rain. So I'm going to put the probability of rain in the denominator. The probability of them both happening was 0.04. The probability of just rain happening was 0.12. Use alpha y equals, and you're going to get an answer of 1/3. So it's really important that you know what your condition is, and you know to put that in the denominator. Also really important that you know what information to actually use, because a common thing on the Regents is that they give you an excess amount of information and you need to pull out which ones do I actually need for this problem. So let's try some Regents questions. We have the data for the students enrolled in a local high school are shown in the Venn diagram below. If a student from the high school is selected at random, what is the probability that the student is a sophomore given that the student is enrolled in Algebra 2? So in order for us to do this, we have the probability of sophomore given Algebra 2. That means we want the probability of them both, of sophomore and Algebra 2, over the probability of just your condition. So over the probability of Algebra 2. Now, when you go and find this, make sure that your probabilities are actually using the total amount of people in the Venn diagram. So your total is really 210 plus 85 plus 320, and a lot of people forget the outside guy of 985. So your total is 1600. The probability of a sophomore and Algebra 2, and probability is going to be found in the intersection of the two circles. So we have 85 over 1600, and then we have the probability of just Algebra 2. Algebra 2 is going to be the entire circle, so that's going to be 210 plus 85, which is there are 295 students taking Algebra 2. your common denominators cancel out, and you are going to be left with 85 over 295. You might be thinking, hey, do I really need those denominators of 1600? Can't I just do 85 over 295? And the answer is yeah. If your denominators are the same, which they should be, you don't have to write them because they're just going to simplify out in the long run anyway. In example 4, we have a study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug. The other half received a sugar pill. The probability of a volunteer receiving the drug and getting well is 40%. What is the probability of a volunteer getting well given that the volunteer received the drug? So this is your condition. This should be your denominator. Before you do anything, you should make yourself a note that you want the probability of getting the drug. And if you read the problem and go back to the top, it'll tell you that half of the volunteers received the drug. So half is going to be 0.5. Or you could write it as 1 over 2, whatever you want. The next part is you need the and probability. So we have the probability of getting the drug, and the other thing going on in this problem is getting well. And the probability of getting the drug and doing well is 40%, so 0.4. Now, we have to find the probability of getting well given that they were getting the drug. So, remember your formula, which is probability of A given B is equal to the probability of A and B over the probability of just B. So if we were to make getting the drug, oh, sorry, never mind. I'll write it out because it'll be better that way. So we have the probability of getting well given getting the drug is the probability of them both, which is the 0.4, over just the probability of getting the drug, which is the 0.5. If you put that in your calculator, you should be getting 2/3. Or 0.6666 repeating. Please do not write 0.666 on your regions. That is rounding. If it's a repeating decimal, you either have to write it as 0.6 repeating or just convert it to a fraction as 2/3. Okay, last example. We have the probability that a resident of a housing community opposes spending money for community improvement on plumbing issues is 0.8. The probability that a resident favors spending money on improving walkways, given that the resident opposes spending money on plumbing issues, is 0.85. Determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. So this one is a bit different because they're not asking you for the conditional probability, they're giving it to you. So you have to think, because they're giving you conditional probability, you should probably be using the conditional probability formula. Or at least, think about it and think about what that formula actually has in it. So this formula has and probability, and that's what we want in the long run. So we can try to use this formula and manipulate it to get our answer of and probability. Now we're going to look at what they actually gave us. So they gave us that the probability of opposing plumbing. And that probability was 0.8. They also gave us the probability of favoring walkways given opposing the plumbing. And that probability was 0.85. So let's make favoring walkways A, opposing plumbing B, and that means this is the probability of B as well. So when I go and input this into my formula, I have the conditional probability was 0.85. We do not know the probability of them both. That's what we're trying to find. And we have the probability of just opposing plumbing, just B, which is 0.8. And we all know how to solve this, right? You're going to multiply both sides by 0.8. And you should end up with 0.68. So you can also write this as a fraction if you choose to. That would be 17 over 25. In general, we don't write probability as a percentage unless the regions problem is specifically saying find the percentage of people or something like that. If it doesn't mention percentage, then you don't have to write the percentage. You can leave it as the decimal here because the decimal is terminating, right? It doesn't go on forever. Let's sum some things up. So for conditional probability, you really have two options on how to solve the problems. Your first option is use a two-way table. Your other option is to use the formula. When using the formula, keep in mind that you can actually use the formula on a two-way table. So if you don't like how the last video explained conditional probability, just use the formula with the table. It works both ways. Anyway, keep in mind that whatever comes as your condition after the line is what should always go in your denominator with the conditional probability formula. And that the numerator, this stands for and, the intersection of them both. And that's all for this video.